good day everyone. Today, me and my friends will be presenting our group assignment project entitled The Impact of Population Density on COVID-19 Infected.
We would like to say thank you to everyone who were involved in the making of this research. People who are involved either directly or indirectly, especially to Puan Hazlena Hanafia as our lecturer. Thank you for your guidance and may God bless you all.
Second, we are also really thankful to God who is making our research success in time. Not to forget to our friends and family, their support and cooperation really take a huge role in making our assignment success.
We hope this research will be useful to everyone out there who wants to know some information about impact of population density on COVID-19 infected or anything related to it. Thank you so much, everyone.
Hi, I am Maxwell Marcelio, and I will continue with our introduction first. Firstly, is the background of study. So as we all know, researchers have confirmed that the COVID-19 virus was first detected in the mainland China from some wet market which developed from animals. It is also verified by experts that this virus is highly contagious and can easily spread just by inhaling droplets of sneeze or cough from an infected person. Places like big cities and metropolitan areas have a higher rate of infection because of the population density factor. And now, after analyzing the infection and death rates of COVID-19 virus at a district level, it is confirmed that there are relations towards COVID-19 infected and population density. Next is the significance of study. So, why is this study important? This study is important to help researchers understand the relationship of COVID-19 infection as population density increases. This study is also significant as it should show people the data information that they need to know about COVID-19 to take precautions as well as fulfilling their rights to know about details and analysis done towards the disease. As we know, this virus is highly contagious and spreading vigorously in crowded population density such as big cities and metropolitan areas. So, if immediate action is not taken, the world will be in jeopardy. Hence, it is necessary for this study to be done. Thus, we believe that COVID-19 infected and population density are very much related. Next is the problem statement. The problem statement is, how does people who got COVID-19 infected affect the society in a specific population density? And following that is the objectives. There are two objectives. The first one is to obtain the numerical information on the impact of population density on COVID-19 infected. And the second one is to determine the relationship between the impact of population density and the COVID-19 infected.
Hello everyone, my name is Nur Shazia Auni and I will be presenting about the methodology of this data analysis. There are 4 data descriptions that I have determined, which are the sample size, data collection method, sampling technique, and also variables. The sample size used in this study was 10, and the data collection method and sampling technique were both none because the data is secondary and is already data. The variables used are population density and number of infections. The type of variable is a discrete variable. This is because The data obtained is a quantitative data, also known as numerical data. Furthermore, the scatter diagram was chosen as our graphical technique because the data is represented by a series of points that reflect observations from two data sets. In this instance, we can see that the population density was plotted on the x-axis, while number of infections was plotted on the y-axis. This is because population density affects the number of infections, but not the other way around. There are three different kinds of scatter plots, which are strong positive correlation, weak negative correlative, and no correlation. Aside from that, we will also interpret the data using two types of analysis. The first one is correlation analysis. Correlation analysis examines the relationship between two variables. We will calculate the sample correlation coefficient, denoted by the symbol R, measures the distance and the strength of the relationship between two variables, which ranges from -1 to +1. The direction and the strength of the relationship is indicated by the sign and the magnitude of the correlation coefficient. This is the Pearson's correlation coefficient formula, the strength of the relationship, and the magnitude of the relationship, which are positive and negative. Moreover, regression analysis is for estimating the relationship between one or more independent variable and dependent variable. It can also be used to assess the strength of the relationship between variables and predict their future relationship. There are several regression analyses, including linear, multiple linear, and also nonlinear. This is the formula for the simple linear model. In addition, 4 numerical techniques will be used in this study, which are mean, median, mode, and also standard deviation. The first one is mean, which also known as the average of the data. These are the formulas for ungrouped and grouped data respectively. It is equal to the sum of all data observations divided by number of observations. Second is median, the middle value. There are two different steps to calculate the ungrouped median, where the n is odd and the n is even. To understand a lot better, you can see the steps here. Whereas for group data, as you can see, there are also specific steps to get the accurate result. Third is mode, which is the value that is most frequently occur in the data. The steps to calculate will be shown in the next slides. Fourth is standard deviation. Standard deviation is a measure of statistical data distribution. The square of standard deviation will be the variance. As you can see, these are the formulas for ungrouped data and grouped data respectively.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Azmil bin Hasan. Today I'm gonna present my chapters, which is chapter 3, result and discussion. For the first one, there are data presentation, which is there's table 1, descriptive information. And for the variable, there are two variables, which is pop density and number of infection. They have minimum, maximum, mean, and SD. So we may go to the descriptive statistic analysis. The table shows a descriptive information for population density and number of infection due to COVID-19. Based on table 1, the minimum value for pop density is 110 and maximum for it is 870. Meanwhile, minimum value for number of infection is 10 and maximum for number of infection is 4,250. As for the mean, pop density mean is 447.10 and number of infection mean is 1,664.70. The table also shows the SD for both pop density and number of infection. The pop density SD is 250.79 and number of infection SD is 1,558.99.
Assalamualaikum, my name is Nur Nabila binti Irwan. Today I am going to explain the correlation and regression analysis under chapter result and discussion. Based on a scatter diagram and regression line, it shows a positive correlation between population density and number of infection due to COVID-19. Hence, as the population density increases, the number of infection due to COVID-19 also increases. The regression equation stated is y equals to negative 1024.1 plus 6.01x, which negative 1024.1 represent the intercept at y-axis and 6.01 represent the slope. Next, it is noted that the correlation coefficient R is equals to 0.967, which is between 0.7 and 1, shows a positive relationship between the population density and the number of infection due to COVID-19. Other than that, the coefficient of determination R squared is equals to 0.936, indicates 93.60% of total regression equation can explain the number of population density by the number of infection due to COVID-19, while the other 6.4% is unpredicted variability of population density. Next, based on the regression analysis summary, the intercept negative 1024.1 means that the initial values is negative 1024.1 and the slope is 6.01. The intercept and population has a standard error which are considered high. In addition, the p-values of both variables is less than significant value of 0.05 and known as statistically significant, in which case the null hypothesis should be rejected. In conclusion, the analysis shows a positive correlation between the population density and the number of infection due to COVID-19. A significant factor of transmission of virus is population density. As population density increases, the number of infection due to COVID-19 also increases. We as a human should control and stop the spreading of the virus by following the standard operating procedure that has been implemented by the government.